So basically, if we need to determine the Fourier transform of cos of omega naught t ut, so in some cases we need to transform, or we need to think, or you need to what should I say, what is the ingredient of the signal in this fashion, if I have to say, like cos of omega naught t ut. If we consider that cos of omega not t can be written as like this fashion. So in this way, if we able to transform some signal into another, then basically our calculation would be very easier. Although in some cases we may try several times how could we solve this. However, the simple trick would be found by which way the calculation will be very easier. So in this video, actually I will try my best to present some examples. So if we transform the cos omega t like that, so after multiplication the calculation would be very easier, because from the properties of Fourier transform we already know that if we have the Fourier transformation of any two signal or three or more signals, we can determine the Fourier transform separately, and then we can sum up. So in this fashion, these are the properties. If we have the Fourier transform of x1t is x1 omega, we can and x2 omega for in case of x2t, then we can multiply the constant with them, and after that we can sum up both of them. So this was the Fourier transformation. So here's the term e to the power j omega naught t ut. Already we have discussed in the previous videos and in the properties of Fourier transform that the Fourier transform of e to the power j omega naught t xt is equal to x omega on omega naught. Here again I am saying that x omega is the Fourier transform of xt. So if we have to determine the Fourier transform in this fashion, we need to know, or we need to have the Fourier transform of xt is given by x omega. We just need to replace x omega by omega minus omega naught t, omega naught, and omega naught can be found from this fashion. So here e to the power j omega naught t ut, we can, if we compare this, so our xt is basically u of t. We know that Fourier transform of ut is pi del omega. So this is in our cases, in that part, if we call it x1t, so the x1 omega or x omega would be that, and we by using this property, actually we should replace this part with omega minus omega naught t, because with u omega, your unit step, the multiplication factor was e to the power j omega naught t. So after having the Fourier transform of ut, we just we got the x1 omega or x omega like that, and we need to replace omega by omega minus omega naught. In similar fashion, we need to replace here. So in this case omega minus omega naught, in this case omega plus omega naught, because here the by comparing these you can simply understand what value would be replaced by omega. So finally, after summing up those, final result will be achieved. So another example in similar fashion, here in this case the xt was cos omega naught t ut. In this case, if xt is the sin omega naught ut, then in similar fashion, if we transform sin omega t by this term, and in similar ways by using this Fourier transform properties, we can determine by using the same Fourier transform properties. Here x1 t and x2 t or xt, simply the x omega was that, here x omega was that, and x1 omega or x omega was replaced by omega minus omega naught and omega plus omega naught. Here the same fashion would be performed. So basically in some cases you need to transform any signal into more convenient or more known format. In this case, your calculation would be very easier. So thanks for watching these videos. Welcome to Fourier transform lecture series. This video I will also discuss some another examples. If we need to transform simply the cos omega naught t, in this case in the similar fashion I have discussed in earlier, here if we think that 1 is multiplied by cos omega naught t, and we if we want to use the property of Fourier transform like that, then x1 t cos omega t, and in this case if we use the modulation property, the ultimate Fourier transform would be x1 omega plus omega naught and omega minus omega naught. We can actually use another Fourier transform, but whatever the process, or in any fashion, or after using any Fourier transform properties, you can when you can finish your calculation, you will find the same answer actually. So in this example actually I want to demonstrate in these fashions. So using the Fourier transform property, you actually transform this. So it's very easier for you. I hope you will understood. You will able to understand each and every examples. So in this similar way and the similar properties you can use for sin omega naught t. So this is the another example when you have to determine the xt. As I have said in several times, that the first thing you need to observe the function or signal that you are given in the exam or any time on when you are practicing yourself. So with a close look we can see that this is the function, and what we have already, this is the function. So if you have a close look on it, you can see that unit step actually been transformed or shifted by the t is equal to 2 actually, or if you place t in second, then 2 second in 2 seconds the signal has been shifted. So basically what can we perform? We have already known that the properties, these properties, the property is that if you have the Fourier transform of xt is given by x omega, then you can play, if you have to determine the x of t minus t naught, that means time shifting, just you need to place, or you need to multiply e to the power j omega t naught. So t naught basically the time or time actually that in which time the signal has been shifted. So basically if you have a close look on it, it is very easier to understand that unit step has been shifted to time second t is equal to 2 seconds. However, if you see this term, actually t is not shifted in a first attempt. You can observe it. However, if you or if we are able to transform e to the power minus 3t into this fashion or time shifting fashion, then our calculation would be very easier like this fashion. So basically here t minus 2. So if we try to replace t minus 2 and after modifying this term, so if we modify e to the power minus 3t like that fashion, so our ultimate goal would be achieved. So this term actually been actually we will able to perform in time shifting properties like that. So in this case, actually e to the power minus 6 is a constant. So for in case of our Fourier transformation, no problem will be happened if we perform the linearity property. Basically, if we have the Fourier transform of xt is given by x omega, then we can multiply a xt x omega in this fashion. You can check the linearity property of Fourier transform. So in this case, e to the power minus 6 can be multiplied with the Fourier transform of that part. So basically this property suggests that if you have the Fourier transformation of xt is given by x omega, just you need to multiply e to the power j omega t naught, where t naught is the time shifting, the amount of time that has been shifted to that point where the signal has been shifted to. So in this case, our next goal is to transform this part. So how could we transform this part? Actually, it would not be difficult for us if we need to or if we are being asked to transform this part of Fourier transform. So in that case, it would be very easier if we have e to the power minus 3t ut. Okay, so in this fashion, our next goal is to transform this part. So actually, we know the Fourier transform of e to the power minus 3t ut is 1 divided by a j omega. So for transforming this part, by comparing that, we actually need to write this fashion 1 divided by a plus j omega. However, here t is replaced by t minus 2, so we need to transform omega x omega multiplied by e to the power j omega t naught. So here the case, so e to the power 3 minus t minus 2, we need to transform this part. So in this case, by using this time shifting property, we need to multiply e to the power minus j2 omega, and here in this case x of t was the here the Fourier transform of that. So where we can get the value of t naught, or here in this case is 2. So as I have said that the time the signal has been transformed into the time second 2, so here 2 is written here, and the Fourier transform of that is in this fashion. So after seeing those properties, actually you will it would be very easier. I hope you will be able to understand that. And after I'm just trying to present several examples in a convenient way, so that it would be very helpful. I will request all of you to discuss with